Hello, geometry. So this is going to be all about the volume of prisms and cylinders. So remember, a prism, there are going to be two congruent parallel faces. And in a prism, same concept, except your bases are going to be circular. So how do we find volume? Volume is three-dimensional. So that means you have the area, and I'm going to use a capital B to represent this. This represents the area of the base, which remember both bases will be congruent, times the three-dimensional height. That's what gives it the third dimension. All right. So to kind of highlight it over here, you have the area of a base, whatever that is, and then times whatever that third height is. So your base could be any of the polygons that we have investigated up to now. So then we have this thing called Cavalieri's principle. If you think about the Leaning Tower of Pisa, so even if your shape is sort of slanted, but the area of the base is the same as the area of the base if it was straight up and down, and the height is the same as if it was straight up and down. It doesn't matter whether it is leaning or whether it is straight up, the volume will be equivalent. So you can treat it as if it is straight up and down. The only thing is you might have to find the height. I'm going to make that a capital H because your height should always be perpendicular to the base. It'll never be the slant height. All right, so it's always got to be like an altitude. So in general, volume, like I said, is going to be the area of the base times the three-dimensional height. And again, the area of this base might be any kind of a shape. It might be a square, so you might just do side squared. It might be a triangle, so you might have to do 1/2 base squared. Any of the shapes we've looked at. It could be a pentagon, a trapezoid, but the area of the base, remember, is, say, centimeters squared, units squared, times the height. That's where you get that third dimension. Okay, so let's look at the volume of some of these. So to start off with, this is a trapezoidal prism because our congruent bases are trapezoids. So this is a trapezoidal prism. And if you don't remember, the area of a trapezoid is height divided by 2, base 1 plus base 2. It's sort of the average of the bases times the height. So let's figure this out. We have here, just to find, we're going to focus first just on the area of the base. So the height is going to be 2.5 divided by 2. Base 1 is 4.4, and base 2 is 5.6. Now all that's going to find us is the area of the base, and so if we're going to find the volume, it's the area of the base times the three-dimensional height. Now since this one is not sitting on its base, the three-dimensional height is going to be 4.2. So this is the area of the base times the three-dimensional height, and then we want to plug all that into our calculator. And so, and really I would just plug it in with using the parentheses as you see it. You will get 52.5, and since it's in meters, it will now be meters cubed. That would be the final volume. All right, so make sure you can plug that into your calculator correctly. So again, we found the area of the base and then multiply that by the three-dimensional height. So here on this next example, again, we're not sitting on our base because that's going to be these triangles. Remember, your bases are always going to be the congruent faces, kind of rhymes. So the first thing we want to start off with is we're going to find the area of the base and then multiply it by the three-dimensional height. the area of our base now is going to be a triangle. And luckily they've given us, so remember the base and the height of your triangle, that's 1/2 base times height, times this now is going to represent big H. That's the distance between our congruent faces. So we know that that'll be 3. And in the triangle, this will represent the height or the altitude of my triangle. This will represent the base of my triangle. So I have 1/2 5 times 8 times my 3-dimensional height. So that's going to be 4 times 15, which is going to give us 60 centimeters cubed, will be my final volume. Okay, so again, break it down into little pieces. Find the area of your base, so it should be a congruent face, and then your 3-dimensional height is that distance between those congruent faces. Now when we go to do the volume of a cylinder, basically it's going to be exactly the same thing. Volume of a cylinder is going to be the area of the base times the 3-dimensional height. The only difference now is the base, because it's a cylinder, will always be pi r squared. So that will be the volume of a cylinder. And again, by Cavalier's principle, my Italian's not so good, even if it's the Leaning Tower of Pisa, it's going to have the same volume if it has the same radius and the same height. All right, so let's do a couple of these examples. We have here a cylinder. And again, I always like to write down my relationships. So in this case, it's going to be pi r squared times, and again, the distance between is going to be my big 3-dimensional height, so that'll be 9.1. And we have pi, my radius is 5, so pi times 25 times 9.1, and I'm going to leave pi in my final answer. If it is big ideas or one of our tests, you just want to follow whatever the instructions ask you to do. And again, this will be meters cubed. So that was times 9.1. All right, now we have ourselves a leaning cylinder, but that's okay, because this is now going to be the 3-dimensional height. It's always going to be perpendicular to the base. So we have volume is going to be pi. My radius is 7, so 49, times my 3-dimensional height. And when you multiply that out, again, I'm going to leave pi as pi. I get 1,078 pi, and my units will be feet cubed. All right, so if you just kind of focus area of the base times that 3-dimensional height, it's not too bad. So now we have, you are building a cylindrical packing tube. You want the length to be 30 inches, so that would be like our overall height, 30 inches. And you want the volume to be 589 inches cubed. So we want to figure out what would be the radius of this. So what I'm going to do is write down the relationship. The volume of a cylinder is pi r squared times that 3-dimensional height. Let's fill in what we know. We know the volume is 589. Pi is still going to be pi. The radius is what we're trying to solve for, and we know the overall height is 30 inches. All right, so we set up our equation. Notice there's only one unknown, so I'm going to divide both sides by 30 pi. Now be careful when you do this if you're doing it on your calculator, because you want to enter that in parentheses. So that will cancel both of those. And let's figure out what that is first. So 589 divided by parentheses 30, using my pi key. That is going to give me, put it over here, 6.25 equals r squared. And of course, we just want r, so we're going to take the square root, and we only care about the positive value of that. So pick 6.25. Second, oh, did that in the wrong order. That's going to give us, oh, a lovely, r will be 2.5. All right? So again, it's a relationship. I really recommend you always write down the relationship and then work from there. Oh, and I should have included units. This is only going to be just inches because radius is one-dimensional. Okay, getting on to, now we have what's called a composite solid. So it's made up of two different shapes. So let's focus on, it looks like 555 tells me we're going to find the volume of a cube, and we're going to add it to half the volume of a cylinder. So they'd cut that cylinder down the middle. All right, so the volume of a cube, we can just do, you know, the reason why it's called a cube is because it's 555. Length times width times height is really what you could do. That's the easiest way. So that's going to be 5 cubed. That's why it's called a cube, which is 125. Now, half the volume of a cylinder, so the area of the base here is going to be half of 5. So I'm going to put it in as half of 5. And then the, I'm such a silly person, sorry. My radius, yes, so here's where, let's write it down. Pi r squared times your three-dimensional height. R is going to be 5 halves, or if you want, you can use 2.5. Probably going to get a decimal in the end anyway. All right, so I've got myself 125 plus half times pi 2.5 squared times the overall height between the two bases is 5. And since one of the answers has a pi and one doesn't, well, you can do this two ways. You could have it as an exact answer, 125 plus 125 over 8 pi, which if you did it all as one decimal should give you 174. Ooh, why is it not writing? Sorry about that. I'm not sure what's happening. And let me write it below. It doesn't seem to want me to go all the way over to the edge. So as a decimal, that's 174.09 feet cubed. So both of those would be acceptable. You just have to look at the instructions to see which one it was asking for. All right. So now we're going to look at the concept of similar solids. We've looked at similar polygons, similar triangles, and you have the same process. I'm trying to move my page and instead it's just making knots. Okay, so a similar solid is going to be one where the corresponding, and again that's the key, the corresponding sides will be proportional. So like all the sides are twice as long as the other shape. And all the angles will still be congruent, or angles between edges. And the scale factor, again, just like when you did it before, is going to be the ratio of the corresponding sides. So you'd find two corresponding sides and find that ratio. Now, here's the interesting thing. The ratio of the volume, because now, let's say the ratio here was A to B. So let's say this was side A, this was side B. That would be, A to B would be the ratio of the sides. The ratio of the volume is going to be A to B cubed. And you can use that ratio, so that's going to be the cube of the scale factor. You use that ratio in order to solve for the volume of something you can't completely find. So here we have two prisms, and they tell us they are similar. Remember that gets the little squiggly sign. And we are given the volume of prism A, but we don't know the volume of prism B. So the first step is to find the scale factor. So we find two sides, and I'm going to do B to A. Well, I'm going to do smaller to larger, just more natural. So 6 to 8 always always reduce that scale factor. So that's going to be, 2 goes into both of them, so that's going to be 3/4. Now, because I'm working with volume, the second step is then to take the scale factor and cube it. So 3/4 cubed is going to equal 27/64. So now I can set up my proportion. So step 3 is set up a proportion. So I'll do that in a different color so we can see. So I'm going to have 27, which is the volume or the ratio for the smaller to the larger, will equal the volume of B to the volume of A, which was given. And at this point, now you're just going to cross multiply and solve. So I multiply 800 times 27, and then you divide by the 64, so that this volume is going to be 337.5 meters cubed, because we're dealing only now with cubes. All right? So again, make sure you always reduce that scale factor, otherwise you're going to get some wacky answers. And before you set up your proportion, you want to cube that scale factor because we're dealing with volume, and then set up your proportions. And I like small to large. It doesn't really matter so long as you're consistent. Now, let's see what they're giving us here. We're given the surface area of 2 similar prisms is in a ratio of 9:25, and we want to find the ratio of the volume. So what I'm going to show you is, let's say I have 2 shapes here. I'm just going to make something up. Okay, and so let's say that these are similar. So what I want you to realize, let's say they're measured, the sides are measured in centimeters. So the ratio of the scale factor is going to be, let's call this one A and this one B. It would be A to B. But the ratio of the surface area, anything that's area, remember area is 2-dimensional, is A squared to B squared, and the ratio of volume is going to be A cubed to B cubed. So what you're going to have to do, they gave us the ratio of the surface area, and they said it was 9:25. So what we first have to do is go back to what is the scale factor. So always find the 1-dimensional scale factor first, like you would in any problem. So that's going to be the square root of 9 over the square root. Actually, I didn't even take my own, that was 25, sorry. I was like, why would they give me 12? That's not a nice number. This should have been a 25. So square root of 9 over square root of 25, so we know that that's 3/5. And so to find the ratio of the volume, you always want to use the scale factor of just the 1 dimension, not the ratio of the surface area. And we cube it. So that's going to be 3 cubed, which is 27, over 5 cubed is 125. That is going to be the ratio of their volumes. Okay? So again, no matter what ratio, if I was given the ratio of the volume, I'd have to take the cubed root to get the scale factor. And then if I wanted the ratio of the surface area, I could square that. But you always want to go through the ratio of the scale factor to get to any other ratio. All right, I hope that all made sense, and see you in class.